One more than the n value. So for number 4, how many terms would there be? 9. If you're given the term number, how can you find k? K is always one less. Yeah. So in this case, all the ones above, I asked you to expand them, correct? Then I gave you a term and asked you for that term, correct? Now I'm not going to give you that. That's why they're a bit harder. So this one here says the term with y5. So what I always do when I'm not sure what the heck to put in, I put in everything I do know for sure exists. So I'm going to put in the x, I'm going to put in the y, and I'm going to put in the n, correct? Because I know those don't change. So let's do that. Grace helped me yesterday. So what you do have to remember is that we have to have a plus sign in between, correct? So we actually have 5 plus negative 2 to the 8. Negative 2y, sorry. So my x is 5. My y is negative 2y. My n is 8. Do you agree? Is that changing on any term? No, those are not what's changing. The only thing that changes is k, correct? So let's fill in everything we do know and then leave a blank for the k's because we don't know what k is. All we know is that the term has to have a y5 in it. So we're going to go n, which is 8, c blank, because I don't know what k is. And then x to the 8 minus blank. And then y, which is negative 2y, to the blank. So once I filled in everything but k, it might help me out more so to figure out what k has to be. I need a term that has y5. What do you think k should be in order to get that to have a term to have y5? 5. Because I only have a y in the second term, correct? And it's a y to the 1. So what would I have to raise it to be 5? 5, right? Now, the catch is these blanks are all the exact same. So if you figure one blank out, you can fill them all in because they're the same number, right? So 5, 5, 5. What's 8C5? Go away. There we go. What's 8C5? Crack out your calculators. Get your money's worth. 56. You might as well use your calculators first off to know if you know how to use it, and second off, they are expensive. Get your parents' money's worth. Okay, 8 minus 5, 3. So 5 to the 3 is 125. And then remember, we have to distribute the 5 to both. So what's negative 2 to the 5? And if you put it in your calculator, remember, you have to put in brackets. You know that's going to be negative because any negative base to an odd exponent stays negative. Any negative base to an even exponent turns positive, right? So negative 5 or 2, negative 2 to the negative 5 is negative 32. Y to the 5. And what would this be? You have to multiply now 56 times 125 times negative 32. It's going to be negative what? Y to the 5. Now, if they ask me for the term, this is correct. If they ask me for what term number contains y to the 5, what would my answer have been? K is 5, so what term is this actually? 6. So sometimes on true and false things, they'll say this is term 6, right? You'd have to know, is that true or is that false? You'd have to figure it out. What's the quickest way? Well, plug 5 in for k, find out what the term is. If it matches this, it's true. If not, it's false, right? If you're given the term number, it's really easy. You just do k1 less and fill it in. The constant term. So people get coefficient and constant mixed up all the time, I think because they start with C's and O's. I'm not quite sure why. But coefficients are what goes in front of a number. So if you have like 2x squared, your coefficient would be 2. If you had negative 4x cubed, your coefficient would be negative 4, right? Your constant is the variable that, or sorry, it's the term without a variable. It's the term that stays constant. And the only way a term can stay constant is if it doesn't have a variable. For example, don't write this down, just pay attention. If I gave you 2x squared plus 3x plus 7, this is function notation. We would have f of x equals this, correct? Now, if I fill in any value for x, what term is not changing? The 7, right? If I fill in negative 2, this changes and this changes. If I fill in positive 7, then this would be 2 to the 7 squared. It's going to change. Plus 3 times 7, which is 21. But is this 7 ever going to change depending on what I fill in for x? No, it remains constant. It will constantly always be 7. The constant is the number without a variable. Okay? So constant is the number without a variable. Term without a variable, I guess I should say. Because it remains constant no matter what I fill in for my x. Now, these constant term questions get asked a lot. You need to know how to do them. People just bank on hoping it's not on there. Don't do that. Don't bank on hoping it's not on your test. It's going to be. Don't bank and hope it's not on your diploma. It probably will be. If not, some sort of form of it. Okay? So, do we know what the constant term is? If they said the constant term was term 7, well, then it would be easy, right? If both of these terms didn't have an x, it would be your last term. That would be the constant term, correct? But because both these have x, we don't know which one's the constant term. We do, however, know n, we know x, and we know y. So we're going to fill those in and hopefully figure out k from there. Okay? So we know that we have 2x plus negative 1 over x squared to the 15. This would be a horrible thing to actually expand. Could you go k equals 0, k equals 1, k equals 2, k equals 3, all the way to k equals 15, do 16 terms and figure out which one doesn't have a variable? Yes. Is that the fastest method? No, that's going to take you forever. They pick really large numbers so that at least if you're going to do it that way, it's going to take you forever to do it. Okay? So let's fill in what we do know. We know n is 15. So we get 15c. The only thing we don't know is k. We know x is 2x to the 15 minus, we're not sure, and then negative 1 over x squared to the we don't know. We agree? Now, in order to get a constant term, when we apply the exponents in, those x values need to have the same exponent, right? Because if, say, the bottom was x to the 6 and the top was x to the 6, they'd cancel off and all we'd be left with is numbers and we'd have the constant, correct? So we need the x's to go away. The catch is this one is x squared. So the exponent that I'm going to apply to it needs to be smaller than this one, does it not? Because if I apply a 3 to here, I'm going to get x to the 6. If I apply a 3 to here, I'm going to get x to the 3. Correct? So this one's going to have to be smaller. So at the very least, we could guess and check till we get it to work out. So don't write anything. Let's just pay attention. I know, however, that this one needs to be smaller. Okay? And I know I have the options of k to 0 all the way to k to 15. Right? Those are my options of k's. If you're putting k to the 20, you're wasting your time. You literally only have 0 to 15. Now I've narrowed it down to it has to be less than half. So it's going to have to be 7 to 0, somewhere in there, right? Because it has to be smaller than the other one. So now I only have 0 to 7 to check. It's not as bad. 7's probably a little bit off, but we can try it out. So pay attention, don't write these. I'm going to try, if I tried 0 here, this one would completely cancel. I'd still be left with an x. Does that make any sense? No. If I tried a 1, My little itty bitty numbers. This is going to be 1, this is going to be x squared, and this is going to be 14. So this will be x to the 14. Are they the same? No. Let's try 2. Little itty bitty 2's. 2, x squared to the 2 is x to the 4, and this will be x to the 13. Are they the same? No. Let's try 3. X to the 6, and then this is 12. X to the 4. Oh, my favorite number. Wouldn't this be awesome? Where is it? Yeah, you can see it. It's totally a 4. It's perfect. This is 11. This is going to be an even number. 5. This is going to be x to the 10. This is going to be x to the... Oh, we found it. It's 5. Oh, I'm going to use a different... If I use the eraser, it'll erase everything. So I'll use a different color. It's 5. Which means this blank is 5 as well. Does that make sense how I did that? You always start with the largest exponent, whichever one has the largest exponent, and start at like, don't start at 0, it's never going to work. Start at like 1, then 2, then 3, then 4, then 5, until they match. Done, right? At least if you're, it's guessing and checking, but if you're guessing and checking in an actual like pattern, it's helpful. But if you're like, I'll try 2, I'll try 10, I'll try 3, like that's not productive. You might miss the one you need, okay? So 15C5 is what? 3003. That's a cool number. I get joy out of little things, okay? This is 10. Don't forget to apply it to the 2. Can you see that that's going to be an error issue? People do that all the time. Don't be that person, okay? 2 to the 10 is something large. 1024. See? Something large. X to the 5. Nope. X to the 10. And then -1 to the 5, it has to apply to both of them. -1 to the 5 is -1. If you forget it, your sign is going to be positive, and you're going to pick the wrong answer because they'll have that there. -1 x to the 10. Those cancel. What's 3003 times 1024 times -1? Anyone get it? Yeah? What other answer are they going to have there? Positive. Right? What other answer are they going to have there? I'd say not applying the 2, the 10 to the 2. That would be another answer I would give. And then I'd give the negative version of not applying the 2. I'd give the positive version of not applying the 2. And then I'd give the positive version of this of not applying the -1. I'd have 4 answers. I'm moving on, and I got all the top errors, right? So if you mess up one little thing, your answer's there. That's the scary part, right? So we need to know everything forwards and backwards. All right. These ones, when they give you the term, you do this in a specific way. So I still fill in, I know my x, I know my y, I know my n, but now I know what it actually equals, correct? So now we're going to actually set it equal to something. This is you only do this when they give you what the actual term is, what it looks like, the full total term, right? You're not solving for it anymore, they gave it to you. But they're missing a piece in the binomial. So let's fill in what we know every single time. We know it's 10 C. Oh, the green's really hard to see. 10 C. I don't know. X to the 10 minus. Not sure. A to the. I have no idea. But it equals 3,281,250 x to the 4. So that term gives me a hint, right? The hint is it has an x to the 4. So I know on the left I have to have it x to the 4. So what's my blank going to have to be? 6. So 10C6, what's that? $210. X to the 4, a to the 6, and it equals the term. What? I must have stepped out the quarters. Oh. And now I can solve for a. People will say, well, how can I solve for a when I have x's? The x's cancel. You have the same one on both sides, correct? So they go away. Now I'm just solving for a to the 6. I have an a to the 6 multiplied by 210. So what am I going to have to do first? Divide by 210. So I get a to the 6 equals 3,281,250 divided by 210, which is? Now, if this were grade 10, maybe even 11, and you had a squared, you take the square root, correct? If you had a to the 6, you take the 6th root. Now, that's not wrong, but I kind of don't want you to use that method so that when we hit exponentials and logs, you're kind of set up for what you need, okay? So, taking the 6th root of both sides works. So if you did do that, you wouldn't be wrong. But what you can do is what we're ultimately trying to do here is we're trying to get the exponent of a to be a 1, are we not? When we take the 6th root, we get a equals blah, and then we have what a equals, and we're good. So ultimately, we're trying to make that exponent be 1, correct? It currently is 6 over 1. What could I multiply it by that would cause my exponent to turn to a 1? 6 over 1, if I multiplied it by 1 over 6, it would be a 1, wouldn't it? And when you're solving equations, what you do to one side, you have to do to the other. So you can multiply this by 1/6. Not multiply it, sorry, raise it to the exponent of 1/6. So we're raising this exponent to 1/6, so we have to raise this base to the exponent 1/6. So actually, when you're taking the square root of a function, you're actually raising it to the power of a half. When you're taking the cube root of a function, you're raising it to the power of a third. That's what you're actually doing. Your calculator's doing it. You're not really thinking about it. In grade 10, they got you to convert bases with exponents into radicals. So in grade 10, you'd have, say, a to the half. What they told you to do was you wanted to convert it to a radical. You'd bring this and make it the index. And then this would stay as the exponent. So it would be the square root of a. Or if I gave you 2/3, x to the 2/3, you'd bring the 3 underneath. You make it be the index. So it'd be the cube root of, and you keep that as the exponent, x squared. We agree? So that's all we're doing. Instead of going the 6th root of a to the 1, we're bringing this back underneath and going a to the 1/6. So in order to get rid of that, we could raise it to the 6 over 1 if we wanted to, right? Make sense? So when you're taking the square root, you raise it to the power of a half. When you're taking the 6th root, you raise it to the power of a 6. Now, if you just went and did the 6th root on your calculator, you'd still get the same answer and it would work. Just when we do exponentials and stuff like that, we're going to have embedded stuff that's not numbers. Maybe like an x plus 2 to the half or something like that. So you need to know how to get rid of it without using a square root because you can't use a square root. There's a variable in it. Okay? So if you just get used to this, sometimes it's helpful. So what's the 6th root or of 15,625 or 15,625 to the 1/6? Now remember, if your exponent pops up, you can go 1 divided by 6. If your exponent doesn't pop up, you have to put fractions in brackets every single time because that's the only way your calculator knows it's a bracket or knows it's a fraction, not a bracket. So if you're putting fractions into your bracket and your exponent does not pop up, you know how you get the little hat symbol and then it gives you your exponent? You have to put your exponent in brackets. Or what it's thinking you're doing is it's going 15,625 to the power of 1 multiplied by 6, or sorry, divided by 6. Is that really what you want? No, you want to the power of 1/6. So when you put fractions in, put them in brackets. Even if you're in one of the calculators where it does pop up, if you put it in brackets, it doesn't harm it. Okay? So if you always put fractions in brackets in your calculator, it'll always work. Because that's the only way your calculator knows it's a fraction is if it's in brackets. So what do you get? A equals 5. Could we try it out? Sure. We could go and plug it in and see if we get the same term back. You could do that. I want you guys to try 7. This one is nicer. Why is this one nicer than the previous one? They gave you what term? So you can get K really, really easily, right? But when they give you this and you're missing a variable out of the binomial, remember you have to set it equal to the term. You have to. Everyone forgets to set it equal and then they just sit there and stare at it. Sadly. Don't be that person. Okay, so we're going to get K equals 10. 13C10 AX to the 13 minus 10 Y to the 10 equals 2,288 X cubed Y to the 10. 13C10 is what? Now let's see if you fell to the common error on this question. 13 minus 10 is 3, right? The 3 has to go to what? A and the X. So you're going to get A cubed X cubed. They're going to have an answer to it just being an A, forgetting to put the cube to it, right? Y to the 10. 2288 X cubed Y10. Y10, X cubed cancels. And so I get 286 equals, oops, A cubed, equals 2288. Divide by 286. A cubed equals what? 8. So they'll let you, most often this question I would bet or guess, I don't know, I went to guess, is going to be a numeric response. It's kind of hard to make this particular question. If I gave you 11th term, it's kind of hard to make it a multiple choice and make errors because the only error you can really do is forget to put the cubed because you're going to catch that you made errors if you use the wrong one. Like say you did K equals 12 and went up by accident, your X's and Y's aren't going to cancel. So you'll catch yourself, right? This is mainly a numeric response question. Take the cube root. We could do this, or what could we have done? Raise it to the 1/3. A equals 2. So this is the homework in your textbook that you haven't done, the blue. And then I'm going to I posted the wrong review. I posted polynomials instead of perms and coms. So I'm going to, once you have this written down, unhook this and put perms and coms up, not polynomials.